Good morning, class. Today we are going on to the gradient and y-intercept of a straight line graph. So gradient and y-intercept, the gradient and the y-intercept of a straight line graph. Okay, now what do we mean by gradient or slope? Okay, a gradient or slope is a measure of the steepness of a straight line. That means how steep is the line. Okay, it's measured by what we call gradient. This is the mathematical term that we use to describe the measure for steepness of a straight line. Now, the general form of a straight line equation is y equals to mx plus c. Okay, just remember this first. I will go through this in detail later. Y equals to mx plus c, where m is the gradient and c is the y-intercept. Okay, m is the gradient and c is the y-intercept. Now, what do I mean by the y-intercept? Y-intercept is the point whereby the line cuts the x-axis. Okay, so this will give us the general form of a straight line equation. Y equals to mx plus c, where m is the gradient and c is the y-intercept, and y-intercept means the point whereby the line cuts the y-axis. Now, for the next part, I would like you to take down the notes on page 181 at the blank space below on the page 181 of a textbook. There's a blank space below page 181 of a textbook. I want to take down the notes that I'm going to show you now. Okay, now first, if the line slopes upwards like that, the gradient will be positive. When the line slopes like that, the gradient will be positive. If the line slopes this way, the gradient will be negative. Okay, take down these two on page 181 at the blank space below. Pause the video if you need more time. Okay. Next, I'm going on to two more types of gradient. Okay, now if it is a horizontal line, the gradient is 0. When it is a vertical line, the gradient is undefined. Okay, because it is not possible for you to walk up a vertical line. That's why the gradient is undefined. This gradient is 0 because there's no steepness. Okay, so this is gradient positive, gradient negative, gradient 0, and gradient undefined. Take down these four pictures on page 181 at the blank space below. Okay, alright. Now next, I'm going to explain to you what we mean by gradient now. Supposing this red line has gradient 2 and this blue line has gradient 4. Gradient 4 is bigger than gradient 2, therefore the blue line is steeper than the red line. Okay? Now, if we have negative gradient whereby it's slant the other way, this is negative 2, this is negative 4. Okay? The more negative, the steeper. So this will be the negative side of it. Now next, I want to bring to your attention that if lines are parallel, they will have the same gradient. This is because parallel lines slant the same way and they will have the same slope. So parallel lines have the same gradient because they have the same slope. So take note of this. Okay? Alright, now next. Let's take a look at some examples. You do not have to copy down this, but you have to remember this. How I do the questions. Okay? Now, I told you that the general form of a straight line equation is y equals to mx plus c. Now, if I tell you that this line has gradient 2 and it cuts the y-axis at 1, that means 1 is the y-intercept. Okay? 1 is the y-intercept. So I'll write y equals to 2x plus 1, whereby this is the gradient, this is the y-intercept. So this is how we write the equation. Okay? Now, let me give you another example. If this line, the gradient is 1, and it cuts the the y-axis at -1, I will have y equals to 1x minus 1. Can you see that this is the gradient, this is the y-intercept? But because 1x will write as 1, so this will be the final equation for the line that is represented. Okay? Now, next, another example. Let's take a look at the third example. This line slopes this way and has gradient -2, and it cuts at 1. So y equals to -2x plus 1. This is the gradient, this is the y-intercept. Okay? Likewise, if you have this line whereby the gradient is -½ and the y-intercept is -2, I will have -½ x minus 2. Okay? So remember, the general form is y equals to mx plus c, where m is the gradient and c is the y-intercept. We will just have to plug in the equation like that in order to get the gradient and the y-intercept. Okay? So that are the examples. These are the examples that I want to show you. And let me just show you 2 more examples. Okay? Now, if I tell you that this has gradient 3 and it passed through the origin, which is 0, so I will actually have y equals to 3x plus 0. But because plus 0 means nothing, so we will leave it out. The final form should be written as y equals to 3x. Okay? Now, then I give you another example on parallel lines. Now, you will see that these 3 red lines are actually parallel. So, the gradient is 2. So, L1, L2 and L3 all has gradient 2, so it's 2x. Note that L1 cuts at 2, L2 cuts at 0, L3 cuts at -3. So, the equation of L1 is y equals to 2x plus 2. Equation of L2 is y equal to 2x because plus 0 we do not write. And L3 has y equals to 2x minus 3. So this will represent the equation of these 3 lines here. Parallel lines have the same gradient, so the number or the coefficient of x is 2. Okay? Now, next, we move on to question for example 7. Okay? For example 7. This is found on page 182. So let us fill in the blanks. Alright? Now let's take a look at the first one. The question says, write down the gradient and the y-intercept of each of the following straight lines. Now this one, as you can see, the gradient will be 2 because it's here, and the y-intercept is 5. Okay? mx plus c. Alright? 2 and 5. For this part, the gradient is 3 and the y-intercept is -1. If we compare to this general form, y equals to mx plus c. Now, for this part c, we have to be careful. We have to do a rearrangement to put the x in front first and the number behind. So, the gradient is actually -2 and the y-intercept is 0.5. Okay? We must make sure that the x comes first, then the number. Alright? Part D, we have to do some manipulations. So let me tell you how we do the manipulations. Now, y is 4x plus 1 over 2. That means it's 4x over 2 plus 1 over 2. 4x over 2 will give me 2x. 1 over 2 will give me half. Therefore, the gradient is 2, which is here, and the y-intercept will be half. So that's how we get the answer to example 7. We always base on the equation y equals to mx plus c, where m is the gradient and c is the y-intercept that we have. Okay? Alright, that will complete our example 7. Now, I am moving on to example 8. Okay? I am moving on to example 8. Example 8 says that the diagram shows the straight lines y equals to 2x plus 1, y equals to -x plus 1, y equals to 3x plus 3, and y equals to -x plus 3. Match the equations to the lines. Okay, now I want you to look here. This line A slopes this way. So the gradient is positive and it cuts at 3. So line A should be 3x plus 3 because this is positive gradient and this is 3, the y-intercept. So gradient the equation for A will be this. Now let's look at the line B. Line B also has a positive gradient and it cuts at 1. So it will match to 2x plus 1. Okay. Let's look at line C. Line C slopes this way, so it's negative. And it cuts at 3. So it's negative x plus 3. Note that negative x means that it's the same as negative 1x plus 3. That means the gradient is actually negative 1. Okay? Look at part D. Part D cuts at 1. So the line D will have the equation y equals to negative x plus 1 because it's a negative gradient. Now I want you to take note that this and this have the same gradient of negative 1. That's why they are parallel. But C cuts at 3 and D cuts at 1. Therefore, this will be the match of the equations. Okay? This will be the match of the equations. Alright? Okay, that will complete your A for example 8. Let's look at example 8 part B. The line y equals to 3x plus 3 passes through the point P0. Find the value of P. Now I want to take note that P represents x and 0 represents y. We substitute in y is 0, x is P. We solve the equation, okay, and we will get P as negative 1. So that is how we do example 8. Feel free to replay the video if you need to look at it again. Okay, the next part, okay, I will be doing exercise 6D. Alright, question 1, 2, 3 and 4. Question 1, 2, 3 and 4. And this will be done on your foolscap paper. So can you check your answers with the foolscap paper? Okay, let me go through exercise 6D question 1 first. Write down the gradient and the y-intercept of each of the following straight lines. For this, it's very simple. The gradient is 3 and the y-intercept is 4. This one, the gradient is negative 2 and the y-intercept is negative 5. For this one, the gradient is 0.2 and the y-intercept is negative 0.3. We just have to compare with the general form y equals to mx plus c. Now, I will give you some time to look at the answers and for you to check your answers. So please check your answers. Okay? Alright, next. For question number 2. For question number 2, there is no need for you to draw the diagram, but you need to write down the answer. Okay? Let's take a look at the question. The diagram shows the straight lines A, B and C with gradients given. Write down the equation of the lines. Now for A, the gradient is 3 and it cuts at 6. So y will be 3x plus 6 for line A. For line B, the gradient is negative 2 and it cuts at negative 5. So y will be negative 2x minus 5. For part C, or line C, the equation should be y equals to negative 3x plus 8. We always go in the form y equals to mx plus c. So that should be your answer to question number 2. Okay, question number 2. Alright, next we move on to question number 3. Okay, let's look at question number 3. They tell us, write down the gradient and the y-intercept of each of the following straight lines. Now note that this is not in the correct manner. We will have to rewrite it. Bring the 3 over into this form. Then we can get the gradient as 4 and the y-intercept as 3. Okay? Always make sure that you write in the form y equals to mx plus c before you can conclude what is the gradient and what is the y-intercept. Likewise for part B, I have to do a rewrite again. So as you can see, this is the gradient and this is the y-intercept. So we have gradient as 0.2 and y-intercept as negative 0.3. For part C, we have to do the division. X divided by 2, 2 divided by 2 is 1. Now x divided by 2 is the same as half x. Remember I said what is in the middle belongs to the top. So this will be my gradient, this will be my y-intercept. So the gradient will be half and the y-intercept will be 1. So that will be your answer to question number 3. Please check your solutions and make sure you understand what is talking about. Okay? Now for question number 4, I will need you to draw the diagram. Just a sketch on the full sketch paper will do. Now this is the diagram that you must draw for question 4 before we start the question. Okay? Before we start the question. Alright, the question says, the diagram shows the straight lines y equals to 2x minus 1 and y equals to 2x plus 4. What are the values of a and b? Now, as you can see, this is a positive value, this is a negative value. Therefore, a must be 4 and b is negative 1. Okay, a must be 4 and b must be negative 1. Now, part B, they say match the equations. Okay, match the equations. Now, you will see that line A is actually 2x plus 4 and line B will be 2x minus 1 because this one cuts at negative 1 and this one cuts at 4. Okay, so it will follow that the answer will be this. Okay, now part C, copy the diagram and sketch the graph of y equals to 2x on it. Now I want you to look at the line y equals to 2x. Y equals to 2x is actually y equals to 2x plus 0. Now I want you to take note here. All these gradients are 2. That means all these are parallel lines. Okay? All these are actually parallel lines because the gradient is the same. Alright? So, how would I draw the line y equals to 2x? So this is how you draw the line y equals to 2x. You will draw it parallel to A and B. This will be the line and it passes through 0 and you will call this line y equals to 2x. So you add this line to y equals to 2x. So it will be a line that's parallel to A and B and it must pass through the origin because the y-intercept is 0. Okay? So that will conclude your exercise 6D, question 1 to 4. That's all for today's lesson. Thank you, class.